Okay, folks, I have 3 gallons of HDX 10% hypochlorite solution that is assumed to be 3,785 milliliters. And with that, I'm going to separate off 350 milliliters of each one of these and put it in this empty acetone jug so that we'll have 1,050 milliliters separate. And that's just so that we have enough headspace to shake these jugs and then throw them back in the freezer with the caps ajar so that we can let the chloroform and acetone react. And hopefully the chloroform will not boil away. I've never had a reaction with this brand in this freezer. As long as we make sure that we're conducting this reaction below about, ideally between -20 to -5 degrees Celsius, that's the best part for this reaction. The colder the better. There is an induction period, you need to be careful, but just make sure the cap isn't on tightly when you leave it to rest, and make sure that you shake it really, really, really thoroughly. And make sure that you start with it as cold as possible. All of these things will help you not have a runaway reaction. We need a total of 375 milliliters of acetone to react with all of this 11.355 liters of bleach at 10% concentration, with all these numbers assumed to be accurate. Anyway, that ends up turning into 34 milliliters into this jug, which we've added 350 milliliters of each of these into. And then to the rest of these bleach bottles, we're going to add exactly 113 milliliters to each of them. That's slightly less acetone so that we have an excess of hypochlorite, because that will help us on the purification, and it will also help us on the long-term management so that we can get rid of this 3 gallons of waste that we're creating today. You'll notice a green color in there. We're gonna not see that green color towards the end of the reaction. It's almost magic how it turns crystal clear, but sodium hydroxide has a yellow-green color in solution, and we're gonna be using up all of this later. Try not to splash this stuff as much as I am. It's not healthy. And we're gonna immediately put this stuff back in the freezer. So today's a Sunday, so it's mostly a cleanup day for me. That means that I just work on little things like this. This is all of the styrofoam that I collected over the past week or so, coming to me through those Chinese packages that always come with, like, you know, styrofoam encased with masking tape, and then any Polar Pop cups or stuff like that. I dissolve it up in acetone to make it into a hard brick. And in order to make a brick this size, you have to have like an entire Walmart bag filled with packing peanuts. So it really shrinks down the size a lot. And then you can just chop that up and throw it in a blender to grind it up into dust. When the dust is heated up, you can decompose it back into styrene, but it also just helps with taking up space that would otherwise be filled in a landfill. So everybody should do that. I'm also drying out some molecular seeds I was using as a trap for my vacuum pump. These need to stay in the hot sun until they stop smelling like weird organic shit. And then over here is the main entertainment. You can see there's a nice sheen of oily contaminants from what I've been working on over the past 2 weeks. Just because it doesn't get filmed doesn't mean I'm not doing chemistry. So all of this oily organic contaminants, these are going to get steam distilled away. This water is very acidic. It contains hydrochloric acid and sulfur dioxide. So I bake a pound of baking soda in the oven at 300 Celsius and then throw the sodium carbonate into this water to neutralize it. And then I've already completed one cycle with about half a gallon worth of liquid that was in 2-gallon jugs. But once this gets boiled down all the way, I'll pour it out onto this tray and let it crystallize out. You can see it's very near the saturation point. So once all of this crystallizes out, I'll pour the liquid off of this back into the pan to be boiled down some more. And all that is going on in the background while the bleach that I just got from Home Depot is chilling in the freezer so that we can make more solvents. Alright, so now we gotta measure out our acetone. For that, I have some really unique antique bottles. I am a pipe layer by trade, and I work on West Kennedy Boulevard for the past 3 years or so. And everywhere around there, if you dig down into the ground about a foot, you'll find these antique medicine, or in this case whiskey bottles. And I have several hundred, at least 130 of them, all the way down from tiny pill bottles all the way to massive 1-liter milk jugs. And we're gonna just use this to hold all of our acetone. I have cleaned it out as best as I could with just hose water, so this should not, all of this should just be mineral deposits that shouldn't dissolve into the acetone. And put it into the bottle. Alright, it's been about an hour and a half, and I've brought my Type K thermocouple with a fresh 9-volt battery in here, and the ambient room temperature is 23 degrees, or 72.5 Fahrenheit. Pop this lid off. You can see this is the old style of lid. Clean strip for their ethanol and acetone has switched to these plastic child-proof lids, which are a lot better. There we go. So you can see there's a metal ring in there and it gets rusted, and it's really easy for the metal cap to get stuck. But let's just take our thermocouple probe Type K. You can see it's been melted by overheating, but it still works just fine. And let's see what temperature the bleach is at. Okay, so we're well within our temperature range. Yeah. Negative 9.5 Celsius, that's perfect. We're gonna work on measuring out 3 portions of 113 milliliters and 1 portion of 34 milliliters remaining. We tap off. So this gets the 34 milliliters. And get your next gallon. I'd remember it's yellow-green now. It won't be for long. Here's and pour that in. Try not to spill. It's been another 30 to 45 minutes, and each one of these bleach containers is like 45-50 degrees Celsius. It's really warm. And I grabbed the metal container and shook it a little bit, and it immediately started giving off some chloroform gas and made the rest of the freezer smell like chloroform. But before shaking it, just smelled kind of like chlorine in there. So we're just gonna leave it shut and hope that things cool down a little bit more quickly, but we're kind of pushing the limits of what this chest freezer can do. I really wanted those bleach solutions to be in the freezer for at least 6 hours to make sure that the reaction had time to cool down. And after about 30 minutes, the temperature wasn't rising anymore, so I quickly, screwed the caps back on in the freezer to let them cool down within the freezer so that hopefully all the chloroform that had vaporized would condense back into the liquid. The problem is, because I had to go to work on Monday, they stayed in there way too long and froze over. So Monday evening I couldn't pour them out, and I had to leave them all Monday night and then all day today. So they've now been sitting for at least, 36 hours. And that's way too long. I'm gonna pour out a small sample into here. We'll start with this one because it seemed like it was leaking, but I think it was just residual condensation from evaporating all day. Oh yeah, there you go. You can see the green color is completely gone. Yeah, that's perfectly clear. Now there's still residual hypochlorite in this, so I actually need to put on some gloves, so I'll be back. The idea is to just pour off as much as we can, like at least 2 liters or so, and then slowly process the rest in 500 ml batches in the SEP funnel. Anyway, let's not splash. No, without disrupting anything. Ooh, that's no good. I slipped and I vibrated things. Let's make sure we didn't lose any. Here we go. Now there's the chloroform. Yep. Here it is. Now that is what it actually looks like when you finally see the chloroform. Oh, looks like the funnel's actually going to make things drip more. The smell of chloroform. It is something that you have to experience before I can describe it to you. It is nothing like ether, but it does have that sweet note of ether. I don't know if the camera will pick it up, but this is water with chloroform. There is a little bit of water left on top, but SEP funnels are nice because with a little bit of swirling, you can coax any suspended droplets down. But it looks like in the time where I was going to get the ring stand, the beaker's already settled. So now I'm going to get that last little bit out with the SEP funnel full of water. So I'm just going to dispense some in. So now I'm just going to dispense some of the water in so that I can wash out that last bit of chloroform into the beaker. And since the rest of this is already rinsed down, I will just discard it. Pour the last piece of chloroform. That would be an awful experience. But here we go. Now we're just going to let this settle while I process the next gallon. it's separating out really well. So you can see as I'm swirling it, it kind of coaxes the smaller bubbles down. And this is the yield of our chloroform. I've got about 300 milliliters. Alright, I went ahead and washed those 2 beakers and got myself 450 mils of water. Doesn't have to be clean, it's just tap water. So I'm going to tap off the chloroform into these beakers, unfortunately, because I'm not going to get out my flask right now. I'm going to go rinse off this funnel because it's getting crusty from the salt solution, so I'll be back. Alright, so I just rinsed it out and cleaned out the outside. So we're going to carefully transfer our chloroform back in. How long it's set, but we're basically just going to do one water washing with a large and make it look like it's a tiny amount. So I got calcium chloride. I'm going to pour some out into this lid to see how much powder I can get out. Alright, so it's definitely got some lumps in it, but I'll just pour the lumps back in. Calcium chloride is regenerable. I'm only going to use a little bit at a time. Or I could bring this down. Yeah. So I'm just going to use a little bit. I can actually hear it hissing from touching water. Now, you shouldn't need much of this shit. There was just water at the bottom, that's what's making it hiss a little bit. But you will rapidly notice this shit will clear up fast. Now, not as fast as anhydrous magnesium sulfate, but you can already see it's happening right there in real time. Now, there is a strong desire to stir, but it's not really necessary except to dislodge stuff that's floating. But you do not need to shake this, you will lose more product. Now look at that. See how quick that was? I've been talking the whole time, and it's already clarifying. Now I'm going to leave this to sit for a second. It might need a little more. There's definitely going to be some dissolved water in this, and we don't want that for distillation, so I think I should add a bit more. But people add way too much drying agent. You really want to go a pinch at a time and spread it out, but don't stir. Yeah, it's hissing like there's dissolved water like a motherfucker in this shit right now. Alright, it's not hissing as much anymore, so now it should be good to just sit on the drying agent for a little bit, and then it should be good to go. So we'll just pour the rest of this unused. So unfortunately this is the best I got for 500 ml bottles right now. I'll keep looking, but I guess I'm going to have to put it in here for now. I do have some antiques, but they're all under a pint. They're all like half pints, so I don't think they'll fit this much chloroform. You can see it's perfectly crystal clear now. It has a little bit of a high refractive index. Better than water. It's very solvent-like. But anyway, let's put it in this bottle. See the vapor front rising? Yes. I should have left more. I think I added like a couple milliliters less of the acetone than I needed to convert it all, so I should have added way less. The fact that it's still this milky